Good afternoon and welcome to Metra AV Tech Tips. I'm Brent.
I'm Adam.
And check out our new logo on screen.
Yeah, isn't that fun? Yeah,
now,
I like that a lot.
We got a couple of different things happening, so this is not what you're going to see on the packaging. But for us and a few other things, this is our go-to gaming style logo.
Well, I think we're going to play around with this and change this out every week or so you all can, see some different fun designs and whatnot. If you see something you like, let us know. Maybe we can get something out to you in like a t-shirt or something like that. It'd be pretty cool.
Absolutely. So, now, let's start with the basics. What do they need to do to keep up with us?
Well, so first and foremost, everybody, thank you for checking in with today's episode. As always, like, share, subscribe, hit the little bell notification to let you know when we do go live, which of course is every Wednesday at 3 p.m. And on top of all of that, of course, we are doing our giveaways still. So the way to get this giveaway, of course, what we are giving away, first and foremost, we're giving away our HDM-AIO2, as well as our CS IR Kit CCUS. Those come as a bundle together because they will be used together is one of the main reasons for that, which of course our AIO2 is our all-in-one fix-it tool, and our CS IR Kit CCUS is our contact closure IR kit, which allows you to learn IR commands, two of them, one for A close and one for B close.
Which is kind of interesting because what we're talking about today.
Yeah, it's a different type of wireless transformation. So today's episode, of course, is Wi-Fi versus Zigbee versus Z-Wave versus Bluetooth versus RF.
So we're catching the wave?
A lot of them. A lot of waves. Really tiny waves, too.
Well, that pretty much covers my surfing of late.
There you go.
But I could ride that.
Yeah, there you go. So today's episode, of course, we are talking about Zigbee, Z-Wave, Wi-Fi, Bluetooth, and RF. And one of the reasons that we're talking about that today is primarily because we had that episode, or that series on networking, and we had a Wi-Fi episode. And honestly, there is so much information when it comes to Wi-Fi. We could almost have an entire show set aside just to talk about Wi-Fi. And honestly, and not even enough time to fill that. We could have an entire series for that.
And let's be honest, we're going to have to cut there's a lot we're going to have to skip in today's show just because of what we're covering.
Yeah, there's so much information. So without further ado, I say we just kind of go ahead and jump right in. And I want to start with let's back up. The giveaway. I want to talk about how to get that. So, of course, the way to get the giveaway, we are doing this for today's episode, and next week's episode on Wednesday is the last one. All you have to do is watch these 4 episodes, the last 2 episodes, today's and the next one. Leave a comment on those episodes about what we're talking about on that episode, or a question at the same time.
Or how awesome we are.
Or that too, sure.
By the way, that's worth extra brownie points as far as you know.
Brownie points, not so much an extra run. But with that said... Anyways, with that said, go ahead and leave a comment and question. We do watch those live. Of course, you can leave that over here in the chat section over here. Or if you're watching this after the fact, you can leave it down in the comment section below. We do monitor those. So if you have a question or a comment, we will respond to those as much as we possibly can.
Let's be honest, it's mostly going to be him.
Yeah, but of course, we'll bring Brent in whenever he's required, which... How often is that?
Apparently this week, you haven't missed me.
Not a whole lot.
This is my first day in the office in... 5 days. 5 days.
Yeah.
And to the best of my knowledge, you didn't even know I wasn't here.
I didn't go looking for you.
You enjoyed the bliss, did you?
Sure, yeah. We'll go with that. So, okay, now let's go ahead and talk about wireless technology and how it works and what it is and what's going on with that. So, Brent, I gave you the task of talking about RF.
Yes.
Specifically things like RS, or sorry, not RS.
Not RS, RF.
433 and
other frequencies. And there are several, but 433 is the primary.
Now, primarily I gave those to you because...
I'm old. And they're old.
So I figured, old and old goes together, so we'll let you kind of run with it, right?
I'm not arguing that. So
now, it's still used today, of course, in many applications.
So move aside. So we maintain our social distancing.
Yep.
And I'm going to step to the front.
Okay.
Hello, all you lucky people. So we're going to start with the basics that all of us that are at least over 45 have been dealing with in our professional years, which is an RF-based system, whether it was early Xantec or Crestron or Fast or Elan or Vantage or RTI. We all dealt with RF, and there's a number of basic advantages to RF. Not the first of which is 95% of RF traffic is one way, meaning your handheld device or your wall-mounted device sends a command and it's received. It doesn't have to negotiate, make sure the things woke up, figure out what's going on. So the delay time is fairly short between the start of the command and the response to the command. The drawback to that is you're not going to send a ton of data over that. And if companies have tried, those of you who have been around a long time remember the two-way Crestrons where you could get some metadata back from your audio player, audio request device where it show you album art and stuff like that, but it took forever to load because the data pass-through is fairly small. The advantage of that is range. When you're looking at a 433 device like a Crestron or an RTI or a Vantage or an older Elan remote, the range could easily be 60, 70, 80, 100 feet in an open environment. And the battery drain was fairly low because you're not sending a ton of data, and in most cases, all you were actually sending was a small bit of data that was an IR command, typically a yes or no, or in the case of Crestron, an ID. In the case of Elan, you actually sent the whole command, which could get a little bit problematic for battery life. But it still was a very effective tool. You penetrated walls nicely, you went through distance, it was great outdoors. The drawback to it again was as the system started to advancing and you wanted feedback, lighting levels or metadata, RF is kind of limited in its ability to support big data packets. And can, but it eats up batteries, and a two-way system, because then you have to have dual frequency, starts chewing up batteries quickly and the device has to get bigger and bigger. And typically when you look at antennas, now somebody's going to say, hey, that's a Wi-Fi antenna. Yes, it is. However, it's also pretty close to your standard 433 antenna at the beginning. You were looking at something like this on your Crestron or your Fast for years and years and years and years. Or if it was on the back of a DirecTV satellite receiver, it was just a little spiral piece of metal that looked like a coat hanger, but about that tall. Now, one of the last 433 devices we were developing was for IR, got down to about this size. Now it does it by actually compacting the wire inside. So you still have the same length of copper, just wound a lot closer, and it quite a bit more engineering to make that work versus this. But 433 is still out there, guys. It still works and it's still effective. I still prefer to, in most cases, two-way communications via Wi-Fi because most times you don't actually need a ton of feedback. And when you look at devices like an RTI or URC, you'll generally have both RF and either Wi-Fi, Bluetooth, or Zigbee. Now, I'm going to step over to Adam on this one because there's a lot of other things on this table.
Yeah.
And some of them are Zigbee, Z-Wave, and Wi-Fi, or some combination.
Now, Brent, do you know the range of what frequencies 433 uses?
You mean how far off 433?
So yeah, so technically there's a little bit of a
well, yeah, it's an EQ curve, effectively.
Yeah, exactly. Yeah, you're looking anywhere from 433.050 to 434.790.
So a little over 1 hertz.
Roughly, yeah, a little over 1 hertz.
Now there were some additional other features, like if you went to URC, they had a lower one. I think it was 428 or 425.
Yeah, that's.
And Crestron also had some devices on that.
Yeah, you're getting into like proprietary stuff. Oh, was this 433? Yeah, there you go.
Alarm guys, you're gonna know these, particularly if you've done a dim coat through the years.
Mm-hmm. Well, and it's still used today.
Absolutely, and you know why? Because all it has to do is send an open and close command and a status for battery.
That's all it is.
It doesn't have to receive anything.
Nope.
So the battery life is a lot longer, and it doesn't require replacement. Typically, you can get 12 to 18 months.
Yep.
On a non-heavily used device.
Well, and on something, exactly, heavily used is the way to look at it, because with something like this, the only time it's transmitting something
is when a state changes.
Is when something changes.
Now, periodically, you will have a polling, meaning that every X amount of time, and this is generally set up in the software of your alarm or whatever device you're interfacing with, a poll, and it will send out a battery status.
Right.
Or it may only send out a battery status if it drops below a given save point.
Yes. Yeah.
Which is also fairly common, and because of that, again, you'll get anywhere from 12 to 18 months life out of a battery.
Yeah, sometimes even longer than that. There are some devices out there, when we talk about the Zigbee stuff primarily also, where you can get years worth of use out of it.
Let's assume we have charged this and we're not using it.
Yes.
How long is this going to sit there
So
and I don't know this. That's why I'm
yeah.
asking.
So something like this. Now, of course, we're talking. Of course, this is the Control 4 SR260, and
Which
one
you
of
and I are
theirs-
both very familiar with. My only complaint with this remote, I really like this remote.
Oh yeah.
My only complaint with this remote is the fonts are just too darn small.
Yeah, well, you're
'Cause
also
I'm old.
Yeah, I was gonna say you're also old. So, but with this remote here, and you're not wrong, the fonts are pretty small on that one. But with that one there, if it's fully charged and we take it off its cradle and we just kind of let it sit there, or if we run it on like 4 AA batteries, something like that's going to usually run in the ballpark of a couple months.
Really?
Never touched.
Never touched.
Though, now here's the thing. It's using Zigbee and Zigbee Pro. Now with something like that, however, though, if it's farther away from the access point for Zigbee or another Zigbee device, because it is a mesh, of course, that's one of the biggest differences.
And this is a two-way communicating device.
And it's a two-way communicating device, but if it is too far away, where it's not getting very many pings back or communication back from a device, it will, over time, use more power because it's continually asking, are you still there? Or am I still connected?
Just like your cell phone.
Yeah, exactly. It's over. If you're inside of a building where you don't have good reception, you're going to run out of battery much quicker than you would if you were outside where you do have good.
Whereas
good
if you
connection.
take like an old school, not the Wi-Fi version of this, but the
No.
basic T1B, or even the T1B Plus without the Wi-Fi turned on, and you don't do a darn thing with it,
Yeah.
it's good for months.
Months and months and
Months
months.
and months
Yep.
and months.
Yep. So with that, I mean, when we're talking about RF, the reason why I really wanted you to start wasn't just because it's the first thing that came out, but really because a lot of what RF was built upon by Wi-Fi and Zigbee and everything
Yeah, it's
else.
all built on that basic platform.
Exactly.
They just increased the frequency and the bandwidth, because the greater the frequency, the more data you can send in a given period of time.
Right. So, of course, we had our episode about Wi-Fi, what was it now? Gosh, almost 4 weeks ago, I believe.
I'll believe you.
Something like that. But on that episode, we talked about like the differences between the 2.4, the 5 gigahertz, and now the new 6 gigahertz network. So when we look at the different communication standards, we realize that, okay, the RF is really great for sending really small packets of information. We're talking bits instead of bytes, or bytes instead of
Again,
kilobits.
typically, when you look at a Crestron, an older Elan, an RTI, URC system, where you have a central base, you're not actually sending the IR command backwards.
Right.
In some cases you do, but typically what you're actually sending is just a simple ID command to the processor where all the information's actually stored.
Exactly. You're almost sending just like an RS-232 string.
It's not even that big.
Yeah, exactly. Which
It will
that's gonna be too
typically, in
big
the
for
case
that.
of Crestron, for example, it's based on what they call a CrestNet number.
Yeah.
Anywhere from 000 to 999.
Yeah.
That's all you're sending, because all the programming is done at the module.
Right.
Now, RTI, if you program at the remote, will send full string. Whatever
Yeah.
commands you put in
Yep.
will send full strings back, and it's just converted to IR.
Right.
Whereas if you program at the module,
It works more like the Crestron.
it works more like the Crestron.
Right.
Most guys program at the remote just because they can see it and it makes
just
more sense.
easier at that point, yeah.
Makes more sense.
Yep.
And in either case, most customers just drop it in the base, and
It's whatever.
it's
Yeah.
still good for 12, 18 months of consistent use.
Yeah. So with something like that, we realized then at that point that we wanted to get more feedback. We wanted to see more response back from the equipment. And so, of course, that's where Wi-Fi started. Wi-Fi, well, started on the data side, but now we started realizing that, oh, we can do more control stuff with Wi-Fi and those types of connections.
And better data, more complete data.
More complete data. So one of the biggest things that we look at with Wi-Fi is that we go from a distance capability of an RF signal of, we're talking in some cases
100 plus feet.
100 plus feet, down to Wi-Fi when it was first introduced, where we're talking about like 20 feet. Well, 150 feet indoors, 300 feet outdoors is the current setup. And that's theory numbers. That's not
Downhill
reality
in neutral
numbers.
with not a blade of grass between you,
Yeah,
between
we're
the
talking
send and receive.
Absolutely no radio. We're talking in a vacuum. No, we're talking absolutely nothing. Now, within reality is, of course, when you're inside, you have walls, you have other things that are interfering
Lighting.
with it, lighting, everything else that's going to be messing with it. So the biggest difference, of course, with that is that we're sending so much more data when it comes to that. We're talking with RF bits of data or bytes of data, or small sections of it. Whereas now with Wi-Fi, we're talking with the new
Reams.
stuff, we're talking gigabytes worth of data. We're talking with the new Wi-Fi 6 capabilities, we're looking at anywhere from 450 megabits, which is roughly the 2.4 gigahertz spectrum starting point, up to a theory of 9.6 gigabytes of
Over
data
wireless.
per second over wireless. Now,
Wow.
yeah, a lot of information. Now, again, that's theory numbers. Those aren't reality
So
numbers.
5 gigs probably closer to truth.
Probably, yeah. 5 to 6 gigs is probably what we're looking at. Even lower
That's
than
still
that,
a
depending on
tremendous
distance.
amount of data.
It's a huge amount of data, but it comes at a limit because, of course, now we have so much data happening in a certain period of time. We need more power. We need a lot more energy put into it. We just had a discussion about this.
Discussion on power, yes.
Yeah, we just did. And actually here, let's see, on the Horizon, the Microsoft back in Azure. Yes, it does. Hey, we got Ellen in the chat.
Hello,
Ellen, it's been
Ellen.
forever since we've seen you. It's great to have you back in the chat with us.
How's the weather today?
Leo, of course, it's always great to have you as well. And we've got Steve Barrett. He says, kudos to the logo designer. I will pass that along. So
yeah,
we're gonna try
he's
changing
much
those
younger
out.
than us, I promise you.
Yeah.
Well, me anyway.
Leo says he just learned that Crestron rides on the Microsoft back end of Azure. That is true. They
On the new stuff.
On their new stuff. Well,
Yeah.
it's not even just their new stuff. It's all their network-based stuff.
Right.
To
me, that is new.
Well, yeah. All of that's run on the Azure system. I'm not sure what the other one was using. What was the home automation system that Brent used when he lived in Bedrock?
Okay. We're gonna go sideways for a second.
Bedrock. Right? He knew Barney and Fred, right?
FAUX.
FAUX.
Fox.
Fox. Okay.
An old RF. Houston Tracker had an RF remote with base station.
Yep.
That sent the full command, so you learn the command into the remote.
Yeah.
And it looked a lot like, strangely enough,
Like
that.
the RTI? Yeah.
It really did.
Okay.
And this was in the late 80s, early 90s.
Ah.
So, yes.
Okay.
So, in Fox, FAUX was early 90s. Sony had an RF egg.
Okay.
Oh, it was this egg thing, and with the GUI around the outside of the screen.
I remember
it
seeing
was
pictures of that.
Horrible.
Oh, yeah.
Because you were constantly.
Would never actually
It
move
would
over
never
like
get
it's
to where
supposed
you wanted it to go. Yeah, it
of
lasted
course.
less than a year.
Yeah.
So, yes, it was Barney days.
Yeah, Barney days. Yeah. Barney Rubble and Fred Flintstone. Let's see, Howlin at the Moon, he says, we prefer Wi-Fi connection with a backup of batteries, or with backup batteries. Yes, for today's technology, for control systems and whatnot, Wi-Fi and IP network systems are perfect for that because we get great two-way communication. Brent and I, on the system that we work on a lot,
We have major battery backups.
major battery backups, and our the TVs that we use, the Sony TVs that we use on that job site, we use Wi-Fi to communicate with them because we get a lot of feedback from those. Actually, in fact, what I'm doing for all you Control 4 guys, I'm using the status of the TV to trigger the TV lift to open and close. I'm not triggering that lift separately. I'm actually using the TV to do that, which makes me wonder. I wonder if that TV's turning on. Anyways, moving on.
We have a separate issue that we have been dealing with on the lift, and that's an interesting thought.
Yeah. Control 4 guys, let me know if you use Sony in a similar fashion that I'm using it to. We're running into a problem where, for some reason, early in the mornings, the lift is just randomly opening up.
The door to the TV garage door.
The Control 4 system is not triggering it, as far as we can tell, and as far as we can tell, we're not having any other issues.
Weirdness.
Or crosstalk or anything like that. Let me know what you think about that over in the comments or in the chat, or you can contact me directly. So when we're talking about Wi-Fi, the biggest differences between Wi-Fi and RF is bandwidth. That's really the biggest difference between that. So now let's jump over into Zigbee. And the reason I want to jump into Zigbee now is because we also are going to be talking about Bluetooth, but Bluetooth really needs to come after those because Bluetooth has kind of moved off to be its own thing.
It's come a long way since the original Bluetooth.
It has, yeah, but now it's kind of moved off to being its own thing entirely, and so it's kind of hard to compare it with the current Wi-Fi, Zigbee, and Z-Wave. So I want to use that as last. So with Zigbee,
Wait, what do all these have in common?
they all use RF. I mean, that's all it comes down to. I mean, if you really want to compare them all, what do they have in common? They all use RF signal.
It's just a matter of the encode decode and how much bandwidth they can handle.
Exactly, and it's just the clock that's coming out of it to know how much data is happening in between that, the frequency that's coming out at, where it's at on that frequency range. With Wi-Fi, of course, we're at the 2.4, which thank you for that. If we look at Wi-Fi, you are using anywhere from 2.4 gigahertz or 2.401 all the way up to 2.495 gigahertz. And it runs in there.
Wow, there's a lot of range in there.
There is a lot of range, and it actually has a channel. It has 14 channels. Here
Control 4 training.
Right? Yeah. Here in the U.S., we're only allowed to use 11.
11?
11. Anyway.
And I remembered that.
Do you remember that?
Control 4
training.
training.
Good job. So we're only able to use 11. Now on the 5 gigahertz range, the channel width of those is 22 megahertz. Now, here's what's cool about that. The 22 megahertz is really interesting because on 2.4, you wind up with a lot of crosstalk with that. So you don't have like one channel by itself. You get a lot of crosstalk. And we talked about that before. And actually, I'm going to draw something here real quick. We'll cut over
By the way,
to this.
the old school guys that did modulators back in the analog days.
Yeah.
Everybody knows you never do adjacent channel. You try to put 5 channels between.
Because you get crosstalk.
Because there's still so much, even at 5 channels, you're not that far apart.
Exactly. So when we look at the Wi-Fi range for 2.4, you've got this, so we had all the way down here, who was the target audience
I'm
of
glad
this
you're reading
screencast?
that because I couldn't see those fonts.
Joe is saying, who is the target audience of this screencast? Like, who are the Control 4 guys? It's up for, well, I mean, I'm a Control 4 guy anyways. So we've got, let's see, we'll do this here. So 2.401 is our starting frequency
What's
down
my
here.
Control system of choice, Adam?
Crestron.
Oh, just checking.
Well, I mean, other than throwing a rock at the button, you've got Crestron. So, I mean, there is that. So 2.495 is the top. And then, of course, you've got, technically, you've got 14 channels. So there's 1, 2, 3, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So on these channels now, of course, we're not able to use...
That's well spaced out and evenly divided.
It's perfect, right? I love it. But in between these channels, there's about 22 megahertz in between these channels. And so in there, what we're dealing with, of course, is the channels themselves, the number of channels that we have is much larger than that. So what we run into is that we've got channel 1 all the way down here at the bottom, and then we've got channel 14, which I'm going to jump down here to channel, let's see, 14, 13, 12, 11, because that's what we use here in the States. So what we normally run into, 11, 10, 9, 8, 7, 6, is a coverage here of roughly this for each channel. So when you are using Wi-Fi on these channels, and then one kind of looks like that, well, what you run into is that you've got all this space here. So if you are using, let's see, 6, 7, 8, 9, let's say you're using channel 9, what you're going to run into is something like this. So if your neighbor is using channel 11, well, guess what? You've got all this crosstalk that's happening right here. So that's why we want to make sure that you have them separated out. Again,
and if he's got a good system that's got a powerful signal,
it could override yours. Exactly. So we covered this on the Wi-Fi episode, so I don't want to get too far into that.
Now, the same thing, by the way, happens on old school RF. If there's something nearby that's broadcasting on a similar frequency, your remote just isn't going to work.
Yeah. Well, and like you were saying, or like I was saying, the 433 range is actually not just 433. You've got 433.0, what did I say, 2.02?
0.9?
0.05. All the way up to 434.79. And so what's happening is you're actually using that range, so you can have crosstalk between the two different devices or between multiple devices.
And by FCC code, the broadcasting device must be pretty limited in power so that it does not step on anything else.
Exactly.
Now, having said that, there was a lot of products built in the early days that were not FCC approved, and anybody that's done lighting by the Big L company knows that those devices will sometimes walk on other things in the house.
Yeah, pretty much.
And while we are not an FCC compliant, we don't do the testing, as powerful as those things are and the interference we see from them in some cases, I have to assume if they're not out of spec, they're right at the bleeding edge of being out of spec.
Yeah. So with Wi-Fi 5, of course, we jump up to 5.15 gigahertz per second. Or sorry, 5 gigahertz.
Is that 5?
5.15 up to 5.895 gigahertz. Pardon me, gigahertz on the Wi-Fi 5. Or 5 gigahertz. On Wi-Fi 6, we go 5.925 up to 7.125. So you got, those ranges are way up there, and that's one of the things that we talked about before, that because they're up there so high, the amount of information that we have leaving that requires more power, for one, because it's a smaller wavelength, and it doesn't travel as far, because again, it's a smaller wavelength. It takes more energy for that wavelength to propagate through whatever environment it's going through.
And just to make it simple, pick up a disc from an old school big band and listen to somebody playing the clarinet or flute and listen to somebody playing the trumpet.
Yeah.
The trumpet projects a whole lot further than the flute does.
Yes, it does.
For the exact same reason.
Yep. That's a really good analogy for it. When you're listening to those two instruments side by side, they could be playing that instrument as hard or with as much air pressure as the other one. However, the trumpet's just going to be that much louder because it's a lower frequency. It's able to go much further because of that. Or the flute, of course, but it's a higher frequency. It's not going to go quite nearly as far. That's usually why.
So there's a whole lot more of them in a band.
There's more flute section, more
you
more
were
people
a
in the
flute
flute
player
section.
in the band, weren't you?
I was not. I was a percussionist. I played the drums back there. Not very well, but I played them.
So I see you as a flute player.
Well, so then we
Maybe the oboe?
So when we're talking about Zigbee, let's go ahead and jump over there. So distances in Wi-Fi, we'll go anywhere from 150 feet on the 2.4 up to 410 feet on Wi-Fi AC, also using the 2.4 spectrum.
For Zigbee?
For Wi-Fi.
Okay.
Now, on Zigbee,
you just said Zigbee.
I know. On Zigbee, we go anywhere from 10 to 100 meters per access point.
Now, and see, that's interesting because we're working on a Zigbee product, and one of the advantages of the Zigbee product we're working on is the range that it provides with the newer chipsets.
Well, exactly, and that's where the 100 feet come in because for the older system, you were looking at 100 to about 50 feet, and now the 100-foot the new chipset
is reasonably stable and reliable at that.
So with the new Zigbee setup with it, and the reason why I said per access point is that's one of the benefits of Zigbee is it's a mesh network. Now, Wi-Fi does have a mesh network system that they've developed after the fact, but Zigbee was developed with mesh
from the beginning.
From the beginning. That was the whole idea behind it.
And it works a whole lot better than 433 repeaters, which really slow things down.
Yeah.
Anybody that remembers old school like X10s and things like that, even though they were power line, it still acts as a repeater.
Yeah, exactly. Well, it's using the same technology. It's just using the power line as the medium to transmit it.
So okay, I got it. I processed it. Let's send it on. The higher the frequency, the processing time is much shorter.
Yep.
So the delay is much tinier between start to finish.
Yep, exactly. So with Zigbee, that's one of the benefits for it is that it has that mesh capability. It's able to send a little bit more information. We're looking at in roughly 250 kilobits per second. So we go from bytes of information on the RF up to kilobytes or kilobits of information on the Zigbee network, which again, that's why you don't see data when it comes to like video or a lot of packet information being sent back and forth on the Zigbee network because it's not designed for that. Zigbee is really designed for, hey, I am device XXXXXXX. I'm in this current state. I need to change to this current state or this next state. That's the information that's being sent off.
And having done a whole lot of Alexa recently, I can tell you that the Zigbee devices typically are faster to respond than the Wi-Fi devices.
Well,
now, part of that's cloud operation, and I get it.
Yeah, a lot of that's cloud.
But
they don't have
if
any
you
direct
can locally
control.
maintain control, which is one advantage of the Control 4 system, the response time drops dramatically.
Yeah. Leo has a really good point. He says, always do a spectrum analysis when at an installation to know where you should place your network. 100% we on our Wi-Fi episode.
I think we covered that in the episode.
We did. On our Wi-Fi episode, I believe the company is ThinkGeek. I forget what company it was that had the part.
Did you add the link to that on the episode?
I may have, yeah. Go back and look at that on our Wi-Fi episode. I believe I put the link in the description about that part, but it's a really great tool. It has a USB part that you plug into your laptop, and it will actually scan your network for RF, not just for Wi-Fi. It scans it for RF, so you can see.
Yeah, noise is noise.
What's happening? Yeah, noise is noise, and so yes, 100% always do a spectrum analysis on that. If you don't have that part, you can use like the Wi-Fi analyzer on your phone. Really, really useful for that.
And particularly if you're in a condo or an apartment building, those can be incredibly problematic for control.
Leo says he was a trumpet player.
So.
So with that, going back to Zigbee,
I bet he played the con.
Sure. Well, I don't know.
Leo,
Anyways.
was it a con?
There it is. MetaGeek Wi-Fi Spy. Thank you so much, the experts, for doing that for us one more time. Yeah, MetaGeek Wi-Fi Spy, great tool. I've used it in the past. It has a lot of good information on it. Thank you so much for that. Okay, so on Zigbee, like I said, we're looking at 250 kilobits of data. So not a lot of data. All we're sending is just information of
on
status.
On, or dim level too.
Dim level. We're sending information like open close, because there are open close like read switches like that, or temperature sensors or whatever else. So usually it's small status instead of here's video from a camera.
Or metadata for like CD covers or something.
Yeah, exactly. So very, very small information. Now, the differences, of course, between Zigbee and Wi-Fi are pretty slim, and the only thing again is going to come down to bandwidth and data bandwidth capabilities. So here's what's cool: Zigbee. If anybody again has done a Control 4 training, I know I'm bringing up Control 4 a lot, but if anybody's done any other kind of Zigbee training whatsoever,
URC,
you are familiar with URC. They do have a Zigbee module, don't they? You are familiar with the fact that Zigbee and Wi-Fi 2.4 share that same spectrum. And so, in fact, you are looking at Zigbee is using the 2.405 gigahertz as the starting point, and 2.48. So you'll remember Wi-Fi 2.4 uses 2.401 and 2.495. So literally right on top of each other is the Wi-Fi and Zigbee. And that's one of its downfalls for Zigbee, is that if you are not careful, Wi-Fi will walk all over your Zigbee connections.
Yeah, the Zigbee is not powerful, but it has limited data bandwidth, so it doesn't have to do a lot, so it's much more battery efficient.
Well, and one of the things that we run into, and we actually ran into it on our job site, is that the remotes, if you're using the Zigbee remotes on like a Control 4 system, if you have a very strong, yeah, I know, right? It's what I know, right? The thing with this is that you run into a problem where you hit a button and nothing happens. And that's because literally the Wi-Fi network is just walking all over that RF signal, and it just doesn't work. And because, again, Zigbee's a relatively low power. It's not trying to go super long distances, because it's trying to use a mesh to go those longer distances instead. So we don't need to use up as much battery.
So you need to look at your channel selection on your Wi-Fi system.
Look at your channel selection. There's a really great tool out there. Usually you want to get onto, I believe it's channel 23 on the Zigbee, and then go to channel 1 or 6 on Wi-Fi, and that's usually completely separating it out. Really, look that stuff up. It's really good information.
Yeah, obviously, it's good to have a Wi-Fi system where you can get in and tune it like that.
Yeah, if it's your Wi-Fi system. And then also, one thing that you can do to combat that as well is more Zigbee nodes. If you're able to add additional nodes to the Zigbee system, that strengthens that wireless signal.
Because the communication doesn't have to go as far.
Exactly. So put in a module. Usually they have like plug-in modules that you can put somewhere else, or you can get like a light control. They're not super pricey depending on who they come from. But you can add those into the system, and it broadens the strength of it, but also the distance that you can go with it. So really cool stuff like that. So now we go to Z-Wave. So here's what's interesting about Z-Wave. Z-Wave is not necessarily a fork of Zigbee, and fork is the technical term for it.
But it's not that dissimilar.
So it was based on the same idea as Zigbee, and that's where it got the Z in its name for Z-Wave. However, it's using a slightly different communication protocol. It's still using a mesh. That's one of its biggest things. However, it goes a shorter distance. So Zigbee, you can go anywhere from 10 to 100 meters. With Z-Wave, you're looking at 30 to 40 meters. So you're not going anywhere near as far as Zigbee on its furthest node. So Z-Wave is really trying to be that shorter distance, more Z-Wave items. And so they're trying to have you fill it out more often in the space.
Are they? And I asked this question, maybe you don't know. Is it less expensive to build a Z-Wave product than a Zigbee product?
That I don't know, but that's a really good question, and I would be curious to see about that. Now, I will say that in a lot of applications...
they both have different marketing groups that are very aggressive.
Yes. Now, I will say that the Z-Wave and Zigbee is most often on the same chipset, so you may have a device that does both. Amazon Alexa is one of those that has both of them on that, I believe. Google may have both on it. Now, Google also has their own communication standard called Thread, which is and it's another competing thing. I didn't go into detail on that this time around because it's not big enough yet for you to really see a lot of it out in the wild. But it's
and other than Google, it's not really out there.
Yeah. So the other thing is that Z-Wave only does about 100 kilobits per second for bandwidth.
Well, we're back to what does it need to do?
Just on, off, and status. That's really all it's looking for.
And the status is just a number of 1 to, is it 2355? Is it, how many?
It may be, so talking
dimming levels?
Bit rates, it may be 255, that I don't know. It depends on the device. Some devices may have like a breakdown of 10 levels. Some may have a breakdown of 100 levels. It just depends on the device itself.
You know, like volume on an Alexa is 10 levels.
Yeah, exactly. Yeah, you can go with something like that. Now with Google, you can go through the whole gamut of, single digits. Alexa is all 10. Now, what's funny about Google is that you can't.
I had a Google device. I gave it away.
Yeah, you can't vocally. Thank you for that, by the way. I use it every day. Google,
is that where it went?
You can't vocally say 22% or volume 22. You still have to say volume 2. But if you go onto the app and actually control it, you can do it that way as well. Yeah. So. Anyways, so the last one they really talk about is Bluetooth. And by the way, if you guys have questions while we're going through this, please ask them in the chat section over here. As always, like, share, subscribe, hit that little bell notification to let you know when we do go live, which of course is every Wednesday at 3 p.m. And then just, or if you're watching this after the fact, leave your comments and questions down below. And don't forget, that's your way to get put into the runnings to win the AIO2 and the CSIR Kit CCUS. So
Bluetooth would be like the gaming controller?
Yeah, so we've got the gaming
I think
controller.
The Apple TV remote is Bluetooth?
I believe, yeah, the Apple TV remote is Bluetooth. The Amazon Fire remote is Bluetooth. We've got the...
I assume the Roku's Bluetooth?
I think the Roku, the newer Rokus are Bluetooth. This is Bluetooth as well, if I remember correctly. This is for the NVIDIA Shield.
Yeah, NVIDIA Shield TV.
Those are all Bluetooth. Your Bluetooth earbuds, of course, for listening to music on your phone.
Some of the keypads for data entry and keyboards and mice.
Lots of things are using Bluetooth because honestly, Bluetooth for a control has become very... I figured you would ask a hard question.
Who is it?
It's the experts are asking,
of course
so what is the difference between Zigbee and Zigbee 3.0? So...
Really?
Primarily, the differences are distance and bandwidth, if I remember correctly, as well as stability.
It's like
and
Bluetooth.
Yeah, it's range of products as well, and capabilities. They've added in a bunch of capabilities.
And I know who asked that question, and he's going to pay for that later.
It's a lot of it's kind of like again, I'm going back to Control 4 because that's what I know. But with Control 4, when they went from their Ember Net to the Zigbee Pro, the biggest difference is that they added to that were security for one, and better capability
and
for
more devices.
More devices, but better capability for those devices.
Because you added there's more addresses available within that system.
Yeah. So
really,
now hold on.
You're going to pay for that.
Do they have Zigbee 3.0?
I don't know.
I don't know. Hold on. Okay. So, anyways,
I don't think so. I don't think I've seen that anywhere.
I think he's asked me a funny question. I'm gonna find out. Zigbee 3.0. You're putting me on the spot, so I'm gonna double check. Yes, it is. It is real. Okay. So, all right. I'll give you that one.
It doesn't mean you're not paying for this later.
Thank you so much. Okay, so what is the format to what is the best format to transmit video over? Wi-Fi. Well, when we're talking about RF signals, Wi-Fi, and
Bluetooth does a decent job at shorter range.
Short range, but it's not nearly as much bandwidth. So with Bluetooth, the highest bandwidth capability of Bluetooth, and actually I've got to look this one up because that one didn't make it onto the sheet.
Bluetooth has expanded its bandwidth quite a bit.
It has. Now, it's still...
Now, we can send 4K, compressed 4K, but 4K over Wi-Fi.
Yeah. Let's see. We'll look this up here real quick.
There is some latency issues.
Bandwidth situation. Oh, and of course, they're not going to tell me on that. But anyway, so the biggest thing with Bluetooth that you're running into isn't so much Screen Innovations does.
Does?
Oh, yes, Screen Innovations is using the Wi-Fi 3. Or, sorry, the Zigbee 3. Is that correct? Is that what you're saying? So with Bluetooth, the really cool thing about Bluetooth is the sheer is less of how much data it can transmit and more how it transmits that data. So with Bluetooth, it's much more security driven. It's designed as a one-to-one device primarily. So you usually have back in when it first was released, it was used for like the earbuds, right, or the earpiece we're talking
The
on Bluetooth.
very first thing I did with Bluetooth, was RS-232 units.
Okay.
I had a lot of issues with Jandy killing downstream RS-232 devices like Elan or automation controllers.
Sure.
So I use RS-232 Bluetooth adapters. And, I kept within 10 or 15 feet, but because there was no physical connection, I quit frying processors.
Ah, so you had an air gap built into it then at that point. So,
and they were very effective for that.
With Bluetooth, because it's that one-to-one communication standard.
Match set typically.
Yeah, pretty much. Yeah, you had a lot more security. With Wi-Fi, you had a lot of
Now, if this was
snooping.
a networking price, what would we call that? It's a VPN.
It uses a lot of that same type of idea or same type of technology. And what happens with that is basically you have that one-to-one communication. So the early days of Bluetooth devices for like talking on it, you could only attach it from one Bluetooth device to one Bluetooth device. It was one-to-one.
Fortunately, that's changed.
Yeah, now you can do multiple Bluetooth devices because of different radios and whatnot. But still, primarily, it's still just a one-to-one setup. It's not really designed as anything else. There's Bluetooth low power, which is allowing more of a mesh design. There is Bluetooth mesh, but again, it's kind of one of those, it wasn't designed that way to begin with.
Well, like a lot of the headpieces that we're using here for our phones.
Yeah.
We'll do two transmitters.
Yeah, exactly.
Or
It'll
two
pick
units.
up two different units.
So I can have my iPad and the computer both hooked up simultaneously.
On your computer, it's got a little USB that
Yes,
you have
it
to plug
does.
into it. So, and actually, in most cases, that's probably a 2.4 RF signal rather than a Bluetooth signal coming from the computer. So, but there are headphones that take two separate Bluetooth connections
and that's
as well.
the ones those that you've seen, that is Bluetooth.
Is it? Okay, cool. So, and then of course we now have, our Bluetooth earbuds, which are doing those as well. So it's
game controllers.
and game controllers and whatnot. Now,
With
usually,
headphone jacks on them.
Usually the game controllers are using, there's multiple Bluetooth receivers in the unit itself, or it's been designed to have multiple radios for it. But Bluetooth really is being used, Bluetooth is really being used more as a control, is what we're seeing. And that's why we see things like the controller, we see things like the remotes. It's
Keyboards.
used for audio. It's getting really high bandwidth audio, really good quality audio, especially with the 5.0 and the aptX capabilities for it. So Bluetooth is really coming a long ways.
iOS used to have a Bluetooth video app. So if you had an iPad and an iPhone, you could transmit video from your iPhone to your iPad if you were in about 30 to 40 feet. It was great for looking behind gear. Unfortunately, the app's gone. I don't know why, but I haven't been able to find a replacement for it.
And I'm looking here.
And what are you looking for?
Looking for data throughput of Bluetooth 5 is roughly 1 megabit per second. So
not great.
Not great, not Wi-Fi, but still fast enough to get good quality audio and still fast enough to transmit data of a certain size over a certain period of time fairly well. Now, it does really well for like low latency applications for like controllers and whatnot, really good applications for that. So for the most part, yes, it does. Yeah, you're right. The experts are saying that the Screen Innovations is using Zigbee 3, and what sucks is that it's not compatible with Control 4 Zigbee.
Of course it's not. Now, that's not uncommon.
Yeah, that's not uncommon, and that's one of the problems of Zigbee is that they're not It's
not.
They're not ruled
It's
by
too much of an open standard.
Yeah, it's a standard, but it's an open standard, so it's too much of an open standard.
Crestron Zigbee doesn't work with other Zigbees.
Exactly.
Control 4 Zigbee is not always interfaceable. URC Zigbee is not always interfaceable with other products.
Now, Z-Wave does have, that's one of the benefits of Z-Wave, is that it is monitored by the Z-Wave corporation or head or whatever
we know
it
that
is.
guy.
Do we know that guy?
That's Mitch Klein.
Oh, okay, great, yeah. Well, you know that guy anyways. I don't know that guy, but you've met him anyways.
Used to be at URC.
Okay, so with that,
And he's
Z-Wave keeps
They keep tight control of that.
keep a much tighter control over it. Now, Steve Barrett is asking, what are the most common problems you hear about with each format on the tech support line? Truthfully, we don't hear a whole lot about it.
The only time we hear about it is when one of those devices is walking on something else, and it's generally because of a failure, a component going bad in the transmitter piece.
So, what about that story about that remote company and our HDMI cables?
Well, now, but see, here's where it gets interesting.
Yeah.
It wasn't our cables. A bunch of years ago, Stuart and I were testing some samples of cables that were sent to us from various manufacturers.
Sure.
And URC was kind enough to provide us a complete programming and hardware suite for our test facility at the time.
Yep.
So we had URC remotes and bases and stuff, and thank you guys.
Yep.
And we would find that with some cables, the remote did not work. Now, it had nothing to do with the remote. This is where it gets a little interesting. If you had an unshielded HDMI cable, it wasn't walking over the remote commands, it was walking over the IR cables.
Oh, it was the IR cables
Right.
that it was running over. So it wasn't even the RF commands
Right.
from the remote.
Now,
okay.
it could walk over that. For example, if you had the antenna, the 433 antenna was too close to a cheesy cable. And a great way to tell this, the guys that got the toner wands,
Yep.
just take it around your HDMI cable.
Yeah.
And if you get a lot of noise, there's no shielding.
There's no shielding, or it's going to run over something.
And the reason, in fact, this is going to take us a segue, but this is important. What's the biggest thing included in an HDMI 2.1 certification?
Oh, this is the for the new test facility.
Yes.
It has to have a certain shielding for the building itself, because they have to verify that the output of that
it's about the cable.
Yeah, yeah.
When you look at an HDMI 2.1 cable, they're not really looking at bandwidth. What they're worried about is the noise, because the FCC was unhappy with the noise generated by, not ours, fortunately, but cheap HDMI cables will generate a ton of noise.
Well, and that was a problem that we've heard. You actually went down a couple years ago. You went down to NASA. Here
and did training down there.
And did training down there, and the thing is that cheap HDMI cables will
interfere with any kind of quality product.
Yeah, exactly. So that was one of the things. Anyways, yeah, continue.
So when you're looking at all of this everything has a failure point. If you're looking at 433, just basic 433 remote, you're only going to send a small amount of data. That's it.
Yeah.
And if all you're sending is a basic command, it's wonderful.
Yeah.
If, however, you need a quick response to that data, it's not going to happen legitimately in 433.
No.
If you're sending a Zigbee command, the problem with Zigbee is if you're outside of the mesh, or you don't have a transceiver nearby, and we dealt with that at that job also.
Yeah.
The consistency of operation is greatly diminished versus RF. If you're dealing with Z-Wave, it's the same thing. If you're dealing with Bluetooth, range becomes an issue.
Yeah.
Now, and Bluetooth really doesn't have much feedback. When you're looking at an Amazon remote or a Roku remote or something like that, or an
there's not
Apple,
really a whole lot
there's no
happening back and
feedback.
forth. No. Yeah, well, and the thing is that the distance as well, it's not, they're not trying to go very far.
No, you're sitting in the living room pointing the remote at the TV, because it also probably has IR commands to do your volume or something like that.
Exactly, yeah. So, anyways, so we're kind of at the end of our today's
at
topic.
the end of our rope.
We're kind of running out of time on this one for today, guys. So as always, everyone who's commented over in the chat, thank you so much. Yeah, it's really great that you're over there doing that.
You're going to pay for that, and I know who sent that 3 comment.
No, he wasn't trying to stump me where he was going with it.
I still. Yeah.
Well, anyways, he put me on the spot for the Zigbee question. But anyways, thank you for putting me on the spot. I needed to learn that. So,
I
Thank
get
you,
to kick
everybody
him
who
in the
did
butt later.
comment in the chat section over here. If, of course, you were checking out after the fact,
Don't forget.
feel free to leave your comments down below. That's your way
Comment
to
to
get
win.
put into the winnings, or put into the runnings for the AIO2 and the CS IRKit CCUS. Just for you, let's see. What are the, oh, okay, you're still typing it up. So anyways, yeah, leave your comments over in the chat section or down in the comment section below. This has been, this is another one of those episodes where if we had spent the entire time trying to track down all the information for this, we could have done a year's worth of episodes on just different Wi-Fi types and everything else. So I highly recommend everyone go out there and do some more research on whatever it is that you're dealing with and find out where you may run into problems with that. One of the things that we run into all the time primarily is on our tech support side there's Alan, is Wi-Fi, because of course we have our Wi-Fi SpyClop systems, and what we see with those, of course, is their distance, the problems that they run into with that. And what you're going to see with that in the troubleshooting is that there are so many things that affect Wi-Fi. It's surprising that it's as advanced, it's as robust as it is. And so with that, or it's widely used as it is, because Wi-Fi does have so many problems, which is exacerbated by, certain types of systems,
environmental conditions
and whatnot. So as always, everybody, thank you for checking in with today's episode. I really appreciate you.
I will say, one of the things you and I have noted doing a variety of AV gear, anytime you can hardwire, do so, because Wi-Fi interfaces are generally the least expensive device they can purchase to put in that product to say, Wi-Fi.
Yeah, no, honestly, if you can hardwire, run a hardwire. I think after all of this, after everything I've learned for RF and everything else, it's a great, awesome opportunity for, certain applications, but you can run a wire.
Run a wire.
Copper, it's not as cheap as it used to be, but it's still cheap enough.
It's not near as bad as a 2x4 now.
Oh, good. Okay. Sony's updated a few things.
Okay.
So... Thanks, Alan. I really appreciate that. Alan says, why do we need to do research if we have really smart men?
She must be talking about another manufacturer.
No. We're really smart because we do research. There you go. And the experts are saying, turn off Bravia Sync in Sony.
Yes.
They just learned that this is a new version of CEC. Or this is their version of CEC.
That is their version of CEC.
Yep. There you go.
And what is the last thing we say when we sign off?
To turn off
Turn
CEC.
off CEC. Everyone call it tech support.
Yeah, well, there's that. And then Steve, of course, is saying Brent and Adam are our path of least resistance for sure. When we appreciate that, we're happy to get this information out there. As always, keep coming back and checking in with the new episodes. Next week, we are talking about AVRs. So we haven't talked about those yet. I'm really excited about it because that's something that is, for a new integrator especially, or for anybody else who's dealing with it, who doesn't deal with those very often, it can be a little frightening.
And there's a lot of changes happening and a lot of things not working the way they should.
Yep, and we'll talk about those as well.
And we get those calls.
Yep, so everybody, thank you for checking in with us today. As always,
go ahead.
Randall is saying, run a wire or use a Wi-Fi router with 8 antennas. In the box, below that box, there is that.
Yeah. The spider.
The spider. Okay, so this is, we got, all right, it's 3:54. We're going to talk about this. Leo, it's 2020 problems, right? I mean, that's kind of what we're dealing with. Leo saying that's because they don't exist for the AVRs.
Well, then there's that.
Yeah, then there's that problem. So, okay, so when we look at the routers that have like 6 or 8 antennas on them, here's the thing: these still are better than just a single antenna. And you're right with that. And I don't know if you're going so far into the joke about it, but it does look silly. It looks kind of funny where you've got 6 antennas sticking out of this thing. This is just a cheap Chinese router that we had picked up as we were testing a few things for some products, making sure that it was going to communicate correctly. But you can see all those. I'm standing in front of a black screen. But
hit the overhead.
There it is. So with this here, with all these different antennas, the truth is that these act in, what's the best word for that?
Tandem.
Tandem? Is that the best word for that?
Well, it works as a diversity system.
Yeah, so what you run into is you have some antennas that act as transmitters, some antennas that act as receivers, some that flip-flop back and forth. You have some antennas that are communicating with certain devices and others that are communicating with other devices.
And they're also checking for multipath to, that's part of the diversity.
Exactly,
to remove
yeah.
it.
So you can have two antennas that are communicating with one device. So let's say these two antennas, because they're using multipath capabilities or MIMO, M-I-M-O capabilities to communicate with that one device. And so what you run into is that you get better throughput because technically you have one 2.4 gigahertz radio and another 2.4 gigahertz radio, or 5. Depending on what it is. So you actually are doubling, or not quite, but you're close to doubling
coupling
your bandwidth capabilities off of that. It's kind of like getting a two WAN connections and using software or hardware to combine those two. It doesn't really work all that well.
Now, here's the thing. You can spend a fair amount of time fiddling with the antennas to get the most reliable throughput.
Yeah.
It's not typically just a matter of, hey, I got 6 antennas and you're done.
Mm-hmm.
Once you start that, it kind of becomes a two-man operation using one of the tools that you mentioned for checking your Wi-Fi system.
Yep.
And while you walk around, the other guy is adjusting the antennas.
Yeah. Randall is saying diversity antennas work. He installed them back in the 80s for microwave systems.
We did it in the cars in the 80s.
Yeah.
For FM tuners.
Yeah.
For people that lived in the cities.
Yep.
Because of multipath off the buildings.
Yep.
It solved a lot of issues.
Yeah, exactly. So, okay, now we really have to close off the day, guys. Thank you so much for checking in with today's episode.
I just sit down.
It's been, I know, right? It's been a really fun time talking about this stuff, and I'm really excited about next week's episode about AVR.
There's still, call us.
So much information, and maybe we'll be able to cover certain things on another episode in the future. If you have any ideas, let us know in the comment section, either here in the chat or down below. Let us know of ideas for things to talk about that you want to know. If you think of anything in the industry or anything that's on the fringe edge of our industry that you want us to talk about, let us know. So
we'll learn it.
We want to learn it. This is one of the things that we do here is learn, and that's what this does for us as well. So, with that said, everybody, thank you so much for checking in with us. As always,
reboot early,
reboot often.
Don't cut your wires too short.
Turn off CEC.
And call tech support. I'm Brent.
I'm Adam.
Have a great day.
We'll see y'all later. We'll see you next time. And don't forget, leave your comments and chats over in the side and down below so you can get in the runnings to win those pieces. Thank you so much, everybody.